सर बहुत बारिश हो रहा है।
बहुत
नेटवर्क में
नेटवर्क का इशू।
नेटवर्क में प्रॉब्लम।
मैं
हाँ
टेंशन
सर।
मत लेना, मैं आज अभी लेक्चर रिकॉर्ड कर रहा हूँ तो इमीडिएटली भेज दूंगा लेक्चर के बाद। बारिश तो बहुत है, नेटवर्क का प्रॉब्लम हो सकता है। घर से बाहर निकलो मत, 2-3 घंटे अलर्ट। लास्ट क्लास we did dipole moment. One question I did 2m upon pi, ऐसा कुछ किया? Define magnetization. This I have done. Hello?
No.
This I have done. Define.
No, sir.
ठीक है. Magnetization. किधर किधर s भी मिलेगा, z भी मिलेगा, सेम है. Define magnetization. The ratio of net dipole moment. The ratio of net dipole moment to the volume of magnet. Ratio of net dipole moment to the volume of magnet is called as magnetization. It is a vector quantity given by m suffix z equals to net dipole moment upon volume, that is m upon v. Its SI unit is ampere per meter. Write down this much. Define magnetization. Ratio of net dipole moment to the volume of magnet is called as magnetization. It is a vector quantity given by mz equals to net dipole moment upon volume equal to m upon v. SI unit is ampere per meter. Ashwin, you are there?
Yes, sir.
So see, suppose it would have been classroom lectures, then wind is blowing.
Sorry, sir.
I said, had it been classroom lecture, wind is blowing so heavy. Yeah. Okay. SI unit is ampere per. If completed, tell, because many definitions I have to do today.
Sir, done.
Okay. Note. Mz is m upon volume. M is 2Lm, that is dipole moment, product of magnetic length and pole strength. Volume is area into magnetic length. That means it is pole strength upon area. So sometimes they can also give you numerical based on pole strength area. So dipole moment upon volume is pole strength upon area is also called as magnetization. Write this as a note.
Done, sir.
State Curie's law for paramagnetic substance. State Curie's law for paramagnetic substance. Paramagnetic substance are those substances which becomes temporary magnet when placed in external magnetic field. So Curie's law, Curie's name of scientist. For paramagnetic substance, the magnetization for paramagnetic substance, the magnetization is directly proportional to the external magnetic field and inversely proportional to the absolute temperature and inversely proportional to the absolute temperature. Therefore, mz proportional B external upon absolute temperature T. Therefore, mz equals to C into B external upon T, where C is Curie's constant. Last line, this is known as Curie's law. Right, good. For paramagnetic substance, the magnetization is directly proportional to external magnetic field and inversely proportional to absolute temperature. Therefore, mz proportional B external upon T. Therefore, mz is C into B external upon T, where C is Curie's constant. This is known as Curie's law. This is known as Curie's law.
Done, sir.
Everybody has that? Last line, this is Curie's law.
Wait, sir.
Done?
Done.
Define magnetic intensity. The ratio of magnetic induction to the permeability of medium is called as magnetic intensity. It is given by H equals to P upon mu or H equals to B naught upon mu naught. It is a vector quantity. Its SI unit is ampere per meter. Right, definition. Ratio of magnetic induction to the permeability of medium is called as magnetic intensity. Yes, completed.
No, sir.
Yes, sir.
Swarno?
थोड़ा 2 मिनट सर.
ओके. कॉलेज में क्या स्टार्ट किया? यही किया. स्वर्णो, आपका कॉलेज में क्या स्टार्ट किया?
सर वो कौन सा यही शायद यही चल रहा है शायद.
मैग्नेटिक मटेरियल चालू किया?
हाँ सर.
ठीक है. ठीक है. तब कर दो.
सर 2 मिनट.
ओ सॉरी, फिर से देखिए.
डन सर.
Then write magnetic susceptibility. Magnetic susceptibility. It is defined as the ratio of magnetization and magnetic intensity. It is given by, ऐसा है, देखो ये ना, इसको चाय चाय बोलते हैं, चाय मतलब लैम्डा के जैसा नहीं है, थोड़ा बीच में ऐसा वायर लाइन है, like this and this. So it is denoted by or given by Greek letter, इसको बोलते हैं चाय, equals to mz upon h. It is dimensionless and unitless quantity. It is dimensionless and unitless quantity. Right. Completed.
यस सर.
तो अभी एक रिलेशन करने वाले, उसके ऊपर मोस्टली दे आस्क वन न्यूमेरिकल. Obtain relation between relative permeability and susceptibility. Relative permeability or and susceptibility, or it is also called as Rowland ring experiment to obtain relation, or Rowland ring experiment. If you have completed heading, then I will rub and complete full derivation. Done, na? Heading is written.
एक सेकंड
फिक्स है इसके ऊपर एक न्यूमेरिकल.
हाँ सर.
What is dielectric constant or relative permittivity? Ratio of permittivity of any medium to that of free space is called dielectric constant or relative permittivity. Same way, ratio of permeability of medium to the permeability of free space is called relative permeability. We want to obtain relation between this relative permeability and susceptibility. Suppose we take a toroid or a solenoid bounded by wire along its length, carrying current I at one end, leaving from other, or toroid. What is magnetic field at any point inside? If there is no magnetic material other than this coil, mu not n I. We have done this earlier. Hello.
Yes, sir.
So in our earlier chapter, we have proved for toroid or for solenoid, if there is no magnetic material inside, then for magnetic field at any point inside in the absence of magnetic material is mu naught Ni. N means number of turns per unit length or per unit circumference. I is the total current flowing through the circuit. एक सेकेंड ना, पहले मैं मैथमेटिकल पार्ट आपको समझा देता हूँ. Consider a toroid bounded by coil of n turns per unit circumference. Then in the absence of any magnetic material, magnetic field at any point inside is V naught equals to mu naught Ni. But if magnetic material such as iron is placed in the core of solenoid or toroid, मतलब एक toroid का अंदर if I put iron और ये solenoid का अंदर if I put iron, तो iron भी magnet बनेगा. So magnetization produced in magnetic material is given by mu naught into mz, where mz is magnetization. Therefore, resultant magnetic induction will be due to current and due to that magnetic material. So we can say B equals to mu naught Ni plus mu naught mz. Now H is same as Ni, because when you compare V naught upon mu naught is H. So V naught is mu naught H. So ये Ni is nothing but H only by comparing. Got it? Hello? Hello?
हाँ सर.
देखो फिर से देख लो. V naught upon mu naught is called H. So V naught is mu naught H, and in toroid this is mu naught Ni. मतलब अपना H क्या है? Ni है ना? हेलो,
हाँ सर अभी समझा।
तो कभी कभी वो लोग खाली ऐसे ही पूछ सकते हैं व्हाट इज H, फाइंड द वैल्यू। तो n into I is Ni by comparison। अभी मैं स्टार्ट से फिर से एक बार लिखता हूँ, पूरा सिंपल डेरिवेशन है, खाली टर्म्स बहुत है, कंसीडर वाला पार्ट बाद में बताता हूँ। सो B naught is mu naught Ni, therefore B naught can be written as mu naught H since H equals to Ni, equation 1. For magnetic material, Pm equals to mu naught Mz, therefore net field is B naught plus Pm, which is equals to mu naught H plus mu naught Mz, but susceptibility is defined as Mz upon H. So Mz equals to susceptibility into H. B equals to mu naught H plus susceptibility into H. So B equals to mu naught H common 1 plus susceptibility, that is mu H equals to mu naught H into 1 plus susceptibility. Both side H cancel. Mu upon mu naught equals to 1 plus susceptibility. So mu R is 1 plus susceptibility. This is relation between relative permeability and susceptibility. Clear? Hello? 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 हेलो,
Yes, sir.
दो चीज नया है, ये Ni को H लिखा और ये Mz का मतलब lambda H, susceptibility. Now we'll restart. While writing, you'll understand perfectly. Right. Consider a toroid bounded with a coil having n turns per unit circumference, bracket small n. The magnetic field in the absence of magnetic material, comma B naught equals to mu naught Ni, but H equal to Ni, therefore B naught equals to mu naught H, equation 1. When magnetic material is introduced inside toroid, then magnetization of magnetic material then comma Bm equals to mu naught Mz, equation 2. Completed?
सर एक से
यस सर।
सबका हो गया?
हाँ सर।
Therefore resultant magnetic field comma B equals to B naught plus Bm. So mu naught H plus mu naught mz, but susceptibility equals to mz upon H. Therefore, mz is susceptibility into H. So B equals to mu naught H plus mu naught susceptibility into H. So B equals to mu naught H into 1 plus susceptibility. That is mu H equals to mu naught H into 1 plus susceptibility. So mu upon mu naught is 1 plus susceptibility. Mu R equals to 1 plus susceptibility. This is relation between relative permeability, and susceptibility. This is relation between relative permeability and susceptibility. Done? Hello? Completed?
Okay, sir.
Okay. Right. So that vibrating bar magnet performs angular SHM, hence derive expression for its time period. देखो स्टेट बोर्ड ने ये न्यूली इंट्रोड्यूस किया है, सीबीएसई में पहले से था, सो आई फील सीईटी वालों को दे कैन एक्सपेक्ट वन न्यूमेरिकल ऑन दिस. So that vibrating bar magnet performs angular SHM, hence derive expression for its time period. Can be asked in 12th also and expected question in CET. Heading I will clear if you say, because entire derivation I want to accommodate. Can I clear it?
Sir.
See, when we have acceleration proportional to minus of displacement from mean position, then it is called linear SHM. Same way by comparison, if it is alpha, that means angular acceleration, directly proportional to angular displacement and directed opposite, then it is called angular SHM. So if the magnet is displaced from the mean position, that means when it was at rest with the direction of the field, then it oscillates on both sides of this equilibrium position. We have to show it is performing angular SHM, hence show that derive expression for its time period. So those who have attended lecture of oscillation, then in that I explained how to get time period of pendulum by using this concept. F equals to ma, that means kx equals to ma. So m omega square x equals to ma. That means omega is a by x का root. इससे time period मिलेगा 2 pi by time. So here we'll say omega as alpha upon theta in root. When I take 2 pi by this, I will get time period. So this concept I am using for vibrating bar magnet. What is torque for a rigid body? Rotating I alpha. This we have done in rotational dynamics. अभी start करता हूँ derivation. Consider a bar magnet to be placed in a uniform magnetic field of induction V bar. Initially, it remains at rest in the direction of field. This is called equilibrium position, because here torque will be mb sine 0, that is 0. So this is called equilibrium position. When the bar magnet is given angular displacement theta and released, then it performs oscillation on both sides of equilibrium position. Forces acting at the two poles are m v bar. These equal opposite forces produces torque given by tau bar equals to m bar cross v bar, which we have already proved earlier. Therefore, torque equals to minus mb sine theta. Negative sign indicates that torque is directed opposite to angular displacement, because we are pushing it in anti-clockwise. Torque is we are pushing it clockwise like this. Torque is trying to bring it back, so it is opposite to angular displacement. Since theta is very small and measured in radian, therefore sine theta is same as theta. So we can say torque is minus mb theta. But torque is I alpha, where I is moment of inertia. So alpha is minus mb theta upon I. Since m, b, I are constant, so alpha is minus constant into theta. So alpha is proportional to minus theta. This shows that bar magnet performs angular SHF. अभी फिर से अच्छे से करता हूँ. Now how to find its time period. Time period. Since alpha is minus mb upon I into theta, so alpha equals to mb upon I into theta in magnitude. So wherever alpha upon theta, I can write there mb upon I. Time period P is 2 pi by omega. So it is 2 pi upon root of alpha upon theta. Therefore, P is 2 pi upon root of mb by I. So P is 2 pi root of I upon mb. This is expression for time period of vibrating bar. Okay? Hello? हेलो हेलो.
Yes, sir.
अभी देखो एकदम स्टार्ट फिर स्लो करता हूँ, आपको एक आइडिया आ गया ना कैसा आ गया. जस्ट लास्ट ईयर निकाल दिया था ये, लास्ट 6-7 साल से. फिर से इंट्रोड्यूस कर दिया है तो मुझे लगता है शायद इंपॉर्टेंट होगा। प्लीज ड्रॉ दिस डायग्राम। बहुत हेवी रेन है।
हाँ सर।
सर डीमार्ट में पानी भर गया।
बाप रे, आपके इधर आपका दूरबीन है क्या, टेलीस्कोप है?
घर से दिखता है सर डीमार्ट।
फिर अगर बोट आया क्या? नहीं, एनडीएफ का, एनआरडीएफ।
नहीं नहीं सर, वो पूरा सामने वगैरह सब भरे अभी। वो बहुत बहुत बार भरा है, कल परसों भी भरा था जब ज्यादा
नहीं,
बारिश हो गया था।
पूरा परेल में तो फिश आ गया था ट्रैक पे। वेदांत, यू आर देयर? वेदांत,
हाँ सर।
आपका चार्टर का जरूरत पड़ेगा अपने को अभी। देखो,
किस चीज का?
चार्टर प्लेन।
चार्टर्ड, अच्छा हाँ।
Right. Consider a short dipole Sn to be placed in a uniform magnetic field of induction B bar. The torque experienced by bar magnet, comma tau bar equals to m bar cross t bar. Therefore, tau equals to minus mb sine theta. Negated sign indicates that torque is acting opposite to the angular displacement. Since theta is very small and measured in radians, therefore sine theta is approximately theta. So tau equals to minus mb theta, but tau equals to I alpha. But tau equals to I alpha. Can I clear full? हाँ. तो आई अल्फा मुझे फर्स्ट चैप्टर से मिला, रोटेशनल डायनामिक्स। In rotational motion, torque is moment of inertia into angular acceleration. If somebody is not knowing, in that chapter you are going to derive. Okay, completed full?
Yes, sir.
Yes sir.
पूरा क्लियर कर देता हूँ. So write down where I equals to moment of inertia alpha equals to angular acceleration. Therefore, I alpha equals to minus mv theta. So alpha equals to minus mv upon I, since m, v, I are constants. Therefore, alpha equals to minus constant theta. So alpha proportional to minus. Thus, vibrating bar magnet performs angular SHF time period. Alpha equals to minus mv upon I theta. So alpha is mv upon I theta in magnitude. Alpha upon theta equal to mv upon I. Since time period comma t equals to 2 pi by omega, so this is 2 pi upon alpha upon theta. So t equals to 2 pi upon root of mv by I. Therefore, t is 2 pi root of I upon mv. So we got time period of vibrating bar magnet 2 pi root of I upon mv. Yes, completed Paul?
Yes, sir.
एक और छोटा सा डेरिवेशन 13A expression for potential energy in rotating format. Potential energy in rotating format. See, since potential energy means work done, so we can say potential energy for bar magnet comma P dot E is integral of T d theta from starting angle 0 to any angle theta. T is nothing but mb sine theta d theta from 0 to theta. 0 means we have assumed that initially it is in the direction of field. So this will become mb. What is integration of sine theta?
Minus
Minus 1.
one.
Yes, 0 to theta. So this will become minus mb, minus I took outside, cos theta minus cos 0. That is equals to minus mb cos theta minus 1. Or you can write this as minus, if you take inside, mb minus cos theta plus 1. That is mb into 1 minus cos. Here we have assumed that starting it was at 0. Copy this one. Derivation is of this. I don't think it will be asked because दो लाइन में ही खाली एक बुक में दे दिया है. Completed? Full?
Yes, sir.
अभी सब जो भी स्टार्ट से बैठा है ना, जरा मैं टॉपिक बोल रहा हूँ, check whether we have done that. Have we explained what is dipole? Magnetic material. Have I explained what is dipole? Hello?
हाँ सर.
हाँ सर.
Just check whether I have explained you dipole. Then magnetic length, axis, equator, dipole moment. किया इतना?
हाँ सर.
Then dipole moment of moving charge QVR upon 2 ये किया है पहले वाले चैप्टर में. Gyromagnetic ratio, gyromagnetic ratio is done for you. It is E upon 2m, which is 8.89 into 10 raised to 10 coulomb per kg. Check.
नहीं सर.
हाँ किया ना?
नहीं सर नहीं.
नहीं किया सर.
क्या बात कर रहे हो, आपके बैच में नहीं किया मैंने ऐसा? Right. Define gyromagnetic ratio. Define gyromagnetic. It is defined as the ratio of dipole moment to the angular moment of moving charge. It is given by lambda equals to m upon L. Its SI unit is coulomb per kg. Its SI unit is coulomb per kg. Completed?
Yes, sir.
Okay. Show that gyromagnetic ratio of moving electron is E upon 2L. So that gyromagnetic ratio of moving electron is E upon 2L. हेडिंग लिखा तो 2 मिनट रुक जाओ, मैं कंप्लीट करता हूँ एंड तक. Consider an electron of mass m, charge q, charge E, moving with velocity v. Its dipole moment capital M is EVR upon 2. Angular momentum again from rotational dynamic, it is MVR. Therefore gyromagnetic ratio comma lambda equals to m by L equals to EVR upon 2 divided by MVR. VR cancel. So this is equals to E upon 2L. Okay, understood till this? Charge unit is coulomb, mass is kg. Therefore, I wrote unit as coulomb per. Copy now full.
Done, sir.
One more line. By chance they ask its value is 8.8 88 into 10 raised to 10. Just two more lines after this, so this topic will get over.
So value क्या थी 8 point?
अभी बताता हूँ, देखो आ जाएगा. E means what? 1.6 into 10 raised to minus 19 or not. Charge of electron. Mass is 9.1 into 10 raised to minus 31. 2 into because it was 2m. So I can write this as 0.8 into 10 raised to this goes up 12 upon 9.1. That is same as approximately 0.8 upon 9 into 10 raised to 12. So this is 8 into 10 raised to 11 upon 9. You can write 80 upon 9 into 10 raised to 10. 9 8s are 72. 8 recurring, 8 will be recurring into 10 raised to 10. So we can write 8.89 into 10 raised to 10 coulomb per K. अगर आया खाली show that E by M तो उधर रुक जाना और show that value is this much, you have to proceed ahead. Completed?
Yes, sir.
Explain origin of magnetism. This is actually last part of the chapter. Rest everything is deleted from CBSE syllabus. And 3 more things are there for our state board. I will do for everybody in the next lecture, but for CBSE student, this is last part. Next lecture, half an hour I will be utilizing to do some theory that is not there for CBSE student. It is only for state board student. Explain origin of magnetism. If this is electron traveling in clockwise, तो current किधर होगा? ये electron है, current. बोलो फटाफट. Electron clockwise, तो current किधर? Anti-clockwise. Current and electron और उल्टा. If current is anti-clockwise, then this phase will behave like north pole और पीछे वाला नीचे south pole. तो ऐसा dipole moment आएगा. ठीक. Then this will be dipole moment. Dipole moment is always directed from south pole to north pole. So if this is south pole, this is north, तो ऐसा जाएगा. Either not south, either north, तो ऐसा है. मतलब in any case it is perpendicular to the orbit. So every substance consists of large number of atoms and molecules. In each atom, there is positively charged nucleus and electron revolving around the nucleus. So I can say circulating electrons are like current carrying loop of certain dipole moment which is perpendicular to orbit of that electron. Orbit of that electron. Now we don't have only one electron in a substance. So this is suppose one orbit, this is second orbit, this is third orbit. So हर एक orbit का dipole moment is perpendicular to that orbit. So there will be different orbit, so different dipole moment. Resultant dipole moment is the vector sum of dipole moments due to electron in different orbit. This is called as orbital dipole moment. That means because of electron orbiting, we have got orbital dipole moment. But like Earth keeps on revolving and also spinning. So this electron is also not only revolving, it is also spinning, also spinning, also spinning. So spin is also a motion. This will also give you current. This will also give dipole moment. So in addition to orbital dipole moment, there is spin dipole moment. The vector sum of orbital dipole moment and spin dipole moment is called as atomic dipole moment. This is origin of magnetism. तो उनका फेवरेट एमसीक्यू है, what is major source of magnetism? Spin motion or orbital motion? Anybody can suggest spin motion or orbital? Who is the major source of magnetism? Same electron is spinning also, same electron is orbiting. Spinning के लिए टाइम कम लेगा, orbiting के लिए टाइम ज्यादा लेगा. तो ये करंट ज्यादा हो गया ना, डिनोमिनेटर कम. Spinning is faster. Hello? So spinning is taking less time, faster है. We also know Earth takes 24 hours to spin and 365 days to revolve. तो कौन सा वाला करंट ज्यादा होएगा, स्पिन की वजह से कि ऑर्बिटल मोशन की वजह से? स्पिन. इसका वजह से फिर करंट ज्यादा, तो डाइपोल मोमेंट ज्यादा. तो मेजर सोर्स ऑफ मैग्नेटिज्म इज स्पिन मोशन ऑफ इलेक्ट्रॉन. कॉन्सेप्ट समझा कि फास्ट हुआ थोड़ा? हेलो हेलो हेलो.
सर एक और स्पिन आप बोल सकते हो?
अभी इलेक्ट्रॉन देखो ऐसा ऐसा घूमता भी है और जगह पे स्पिन भी होता है. तो स्पिन मोशन से भी करंट मिलेगा, उसका वजह से जो डाइपोल मोमेंट आता है उसको बोलते हैं स्पिन डाइपोल. स्पिन ऑर्बिटल का जो टोटल है वेक्टर, उसको बोलते हैं एटॉमिक डाइपोल मोमेंट. इसके वजह से हर एक एटम में मैग्नेटिज्म प्रॉपर्टी डेवलप होगी. बट मेजर कॉज इज स्पिन मोशन ऑफ इलेक्ट्रॉन. यस कनव. हेलो. हेलो.
हाँ सर.
कुछ डाउट है क्या? चलो लिखते रहो, लिखते लिखते समझ जाता है बहुत बार. राइट. एवरी, अभी इसमें डाउट आएगा तो मुझे प्लीज रुका देना. एवरी सब्सटेंस consists of large number of atoms and molecules. Each atom consists of positively charged nucleus and negatively charged electrons circulating around the nucleus. The circulating electrons are like current carrying loop of certain dipole moment perpendicular to that orbit. Now, anybody who has not followed in this paragraph anything? Yes, Anushka? Manasvi?
Yes, sir.
Any doubt?
No, sir.
No, sir.
No? Arya? Ananya?
No, sir.
No, no? Okay.
से लास्ट लाइन क्या लिखा है?
Perpendicular to that orbit. Have you completed till end? Perpendicular to that orbit. Sahil, done till end? Yes, Vedant?
Yes, sir.
Okay. Next paragraph. As different electrons revolve in different orbits, inclined to each other. Hence, resultant dipole moment is the vector sum of dipole moment due to electrons in different orbits. This is called as orbital dipole moment. Last paragraph. In addition to orbital motion, the electrons also spins and gives rise to spin dipole moment and gives rise to spin dipole moment. One last paragraph. The vector sum of orbital dipole moment and spin dipole moment is called as atomic dipole moment. This is origin of magnetism. Then write note. Major source of magnetism is spin motion.
सर नोट में क्या लिखा है एक बार रीड कर सकते हो?
Major source of magnetism is spin motion.
ओके
हो गया लिखे पूरा? हेलो?
हाँ सर हो गया.
That's all for today. I will just check what portion more is there. If something is there, I will teach. If nothing is left out, then we'll be doing numerical. After numerical, we will start with new chapter EMI. So Friday will be this same chapter. Monday onwards, I will start with new chapter, that is EMI. So that's all for today. This Sunday you will have test on only magnetic material. Very small chapter, very simple chapter. So today we shall stop here.
Yes, sir.